DTrace is a comprehensive dynamic tracing framework created by Sun Microsystems for troubleshooting kernel and application problems on production systems in real time. Originally developed for Solaris, it has since been released under the Free Common Development and Distribution license and has been ported to several other Unix-like systems. DTrace can be used to get a global overview of a running system, such as the amount of memory, CPU time, file system and network resources used by the active processes. It can also provide much more fine-grained information, such as a log of the arguments with which a specific function is being called, or a list of the processes accessing a specific file. Oracle has begun porting DTrace from Solaris as a Linux kernel module. Description: Sun Microsystems designed DTrace to give operational insights that allow users to tune and troubleshoot applications and the OS itself. Testers write tracing programs using the D programming language. The language, inspired by C, includes added functions and variables specific to tracing. D programs resemble awk programs in structure. They consist of a list of one or more probes, and each probe is associated with an action. These probes are comparable to a point cut in aspect-oriented programming. Whenever the condition for the probe is met, the associated action is executed. A typical probe might fire when a certain file is opened, or a process is started, or a certain line of code is executed. A probe that fires may analyze the runtime situation by accessing the call stack and context variables and evaluating expressions. It can then print out or log some information, record it in a database, or modify context variables. The reading and writing of context variables allows probes to pass information to each other, allowing them to cooperatively analyze the correlation of different events. Special consideration has been taken to make DTrace safe to use in a production environment. For example, there is minimal probe effect when tracing is underway, and no performance impact associated with any disabled probe. This is important since there are tens of thousands of DTrace probes that can be enabled. New probes can also be created dynamically. Command line examples: DTrace scripts can be invoked directly from the command line, providing one or more probes and actions as arguments. Some examples: scripts can also be written which can reach hundreds of lines in length, although typically only tens of lines are needed for advanced troubleshooting and analysis. Over 200 examples of open-source DTrace scripts can be found in the DTrace toolkit, created by Brendan Gregg, which also provides documentation and demonstrations of each. Supported platforms: DTrace first became available for use in November 2003, and was formally released as part of Sun's Solaris 10 in January 2005. DTrace was the first component of the Open Solaris project to have its source code released under the Common Development and Distribution license. DTrace has been ported to FreeBSD and NetBSD. Apple added DTrace support in Mac OS X 10.5 Leopard, including a GUI called Instruments. Over 40 DTrace scripts from the DTrace toolkit are included in bin, including tools to examine disk I/O and process execution. Unlike other platforms that DTrace is supported on, Mac OS X has a flag that a program may set that disallows tracing of that process by debugging utilities such as DTrace in GDB. In the original Mac OS X DTrace implementation, this could affect tracing of other system information, as unrelated probes that should fire while a program with this flag set was running would fail to do so. The Mac OS X 10.5.3 update addressed this issue a few months later. The Linux port of DTrace has been available since 2008. Work continues actively to enhance and fix issues. There is also an active implementation on GitHub. Standard core providers are available, plus a special INSTR provider. The Linux DTrace implementation is a loadable kernel module, which means that the kernel itself requires no modification, and thus allows DTrace to avoid CDDL versus GPL licensing conflicts. However, Once DTrace is loaded, the kernel instance will be marked as tainted. In 2007, a developer at QNX Software Systems announced on his blog that he and a colleague were working on incorporating DTrace into the QNX operating system. Oracle Corporation added beta DTrace support for Oracle Linux in 2011. DTrace is available as a technology preview in the Unbreakable Enterprise kernel Release 2, which is under GPL2. In December 2012, Oracle announced the general availability of DTrace for Oracle Linux. Language and application providers. Language providers supported by DTrace include assembly language, C, C++, Java, Erlang, JavaScript, Perl, PHP, Python, Ruby, Shell Script, and TCL. With a supported language provider, DTrace can retrieve context of the code, including function, source file, and line number location. Further, dynamic memory allocation and garbage collection can be made available if supported by the language. Application providers allow DTrace to follow the operation of applications through system calls and into the kernel. Applications that offer DTrace application providers include MySQL, PostgreSQL, Oracle Database, Oracle Grid Engine, and Firefox. Authors and awards. DTrace was designed and implemented by Brian Cantrill, Mike Shapiro, and Adam Leventhal. The authors received recognition in 2005 for the innovations in DTrace from InfoWorld and Technology Review. DTrace won the top prize in the Wall Street Journal's 2006 Technology Innovation Awards competition. The authors were recognized by Usenix with the Software Tools User Group Award in 2008. See also: FTrace, a tracing framework for the Linux kernel, capable of tracing scheduling events, interrupts, memory mapped I/O, CPU power state transitions, etc. FTrace, a BSD Unix and Mac OS X utility that traces kernel program interactions. FTrace, a Linux debugging utility, displays the calls a user and application makes to shared libraries. FTrace, a debugging utility for Linux and some other Unix-like systems, monitors system calls used by a program and all received signals. System Tapa, a scripting language and utility used for instrumenting Linux installations. LTTNG, IBM Probe View. VMWAREVPROBE, references, Brian Cantrill. Hidden in plain sight. ACMQ4. 26 a 36 doi, 10.1145/1117389.1117401. Retrieved September 8, 2006. Brian M. Cantrill, Michael W. Shapiro and Adam H. Leventhal. Dynamic Instrumentation of Production Systems. Proceedings of the 2004 Usenix Annual Technical Conference. Retrieved September 8, 2006. Notes. External links. DTrace tools. Brendan Gregg's DTrace examples. FreeBSD DTrace page. FreeBSD DTrace homepage includes a tutorial and one-liners. DTrace ebook. Includes hundreds of example scripts online. DTrace ebook scripts. DTrace ebook scripts on GitHub. DTrace toolkit. A collection of DTrace scripts. DTrace hands-on lab, a step-by-step course to learn DTrace. Blight tutorial. Blight is an interactive graphical observability tool for C++ developers based on DTrace technology from the Oracle Solaris Studio, exploring Leopard with Trace. How to use DTrace for debugging and exploration. Tech talk on DTrace given by Brian Cantrill.